In the previous proposition, we showed that parallelopipeds sharing the same base, but skewed around, are the same volume. We'll now show that parallelopipeds on equal bases and equal heights are the same volume, so no longer the same base. This makes sense because the volume of a parallelepiped is the base times the height, so if the bases and height are equal, the volume is clearly equal. So let's prove this with Euclid. Start with parallelopipeds AE and CF, whose equal bases are AB and CD, and equal heights. To begin, let's first assume BE and DF are perpendicular to their bases. Extend CR to get RT equal to HB and draw angle TRU equal to angle BHA, and then UW equal to AL. And essentially, make a parallelepiped RV equal to parallelepiped HM. Then skew parallelepiped RV to get a new parallelepiped RC that shares the same base, Rx, with parallelepiped RV. Two propositions ago, we showed parallelepiped RC equals parallelepiped RV, so parallelepiped RC equals parallelepiped HM. Now construct parallelepiped RI. Consider the parallelepiped CI. The plane RF is parallel to CQ, and TI has cut the parallelepiped, so parallelogram CD to parallelogram DT is proportional to the parallelepiped CF to the parallelepiped RI. Consider now parallelepiped YI. It has also been cut by a plane RX parallel to YC and DI, so parallelogram YT to parallelogram DT is proportional to parallelepiped YX to parallelepiped RI. So between those two propositions, parallelepiped YX equals parallelepiped CF, but parallelepiped YX is equal to parallelepiped HM, so parallelepiped CF is equal to parallelepiped HM. Let's now look at these two parallelepipeds. The parallelogram GE is equal to parallelogram QS, and the heights are the same. From the parallelogram GE, take all four of its corners and drop perpendiculars to make a parallelepiped of the same height as its parallelepiped. Do the same for parallelogram QS. We just showed in this proposition that parallelepipeds of equal bases and height with perpendicular edges are equal, so parallelepiped GT equals parallelepiped QI. And the last proposition showed parallelepiped GT is equal to parallelepiped GB because they are of the same base and equal height. Similarly, parallelepiped QI equals parallelepiped QR, so altogether parallelepiped GB is equal to parallelepiped QR. Overall, parallelepipeds of equal bases and heights are equal.